So kinematic diagram show VT graph for particle q travel in a straight line with velocity v at time t. The particle accelerate at 3.5 meter per second square for the first 10 seconds of its motion and then travel at a constant velocity v for 10 seconds. Then decelerate at a constant rate and come to rest. Distance travel during the interval between 20 and 25 is 112.5. Find the value of v. So um this is 10v and this is 0, 0. So we have the 10v and 0, 0 here. So for VT graph, acceleration is equal to gradient. So gradient is the acceleration. So the acceleration is 3.5. So that means the gradient v minus 0 over 10 minus 0 is 3.5. So v is 35 meter per second. Okay, so 35. So this is 10, 35, and then this is 20, 35, and then we have the 25v here. Okay, so find the velocity of q when t equal to 25. So for VT graph, we know that the area under the curve is equal to the distance. So this one, the area will equal to 112.5. So the area is 112.5. Okay. So this is phi, this is v, and then 35 here. So half v plus 35 times phi equal to 112.5. Okay, so the v plus 35 equal to 112.5 divided by 5 and then multiply with 2. So it's 45. Okay, so v will be 10. Okay, so the velocity is 10 here. This is 10. Find the value of t when q come to rest. So we have t 0. Their gradient will be the same. Okay, so 25, 10. So we have the 20, 35. So we have the 20, 35, 25, 10, and the t0, their gradient are same. So we have the 0 minus 10 over t minus 25 equal to 10 minus 35 over 25 minus 20. Okay, so this is negative 25 and this is 5, and we do the cross multiplication. Then we will have the negative 10 times 5 equal to negative 25 t minus 25. So negative, negative cancel. So 5, 5, and then 5, 2. So we have the t minus 25 equal to 2. T is 27 seconds. Then for question number 2, diagram show the VT graph of particle P travel 2775 meter in 90 seconds. Reach a final velocity of v. Find the value of v. Okay, so I can separate this one into 3 parts. Okay, 2 parts, trapezium and trapezium, or I can separate this one into 2 parts. So I think is maybe for some students 2 part is easier lah. Then this is 40, and then 30, then 30, and this one is V. Okay, so we have the half times 20 times 30 plus 40 times 30 plus half 30 plus v times 30 equal to 2775. Okay, then we can find the value of v. And over here, we will have 300 plus 1200 plus this one is 15v plus 30 equal to 2775. So v plus 30 is 2775 minus 300 minus 1002, 1275. Then divide by 15 is 85. So v is 55 meter per second. Okay. So acceleration when t equal to 40. Uh, acceleration 0. Okay. 0. Okay. Because the in VT graph, acceleration is the gradient. So for this case, the gradient is 0. Okay. So the answer will be 0. Question number 3. Displacement x of a particle from a fixed point at time t is given by this. Find the acceleration. So we know that v is dx dt. So first derivative, so differentiate cos will be negative signs. Negative 6 sine 3t plus pi over 3 divided by multiply by 3. Okay, so it will be negative 18 sine 3t plus pi over 3. And then next we want to find the acceleration. So we know that the acceleration is dv dt. Then it will be negative 18 cos 3t plus pi over 3. Then multiply with 3. Negative 54 cos 3t plus pi over 3. So when t equal to 2 pi over 3, the acceleration will be negative 54 cos 3 2 pi over 3 plus pi over 3. Then 2 pi plus this will be equal to cos pi over 3. Cos pi over 3 is cos 60 is half. Then is negative 27. Okay, negative 27. Okay, meter per second square. Question number 4. A particle P move in a straight line t second after pass through a fixed point O, acceleration is a equal to negative 6. When t equal to 0, the velocity is 18. Find the time p come to rest. Okay, so we know that the a equal to negative 6 for all the time. So v is integrate a dt will be integrate of negative 6 dt, then is negative 6t plus c. So when t equal to 0, v equal to 18. So 18 equal to 0 plus c, c is 18. So v is negative 60 plus 18. So at rest, v equal to 0. So we have the negative 60 plus 18 equal to 0. 60 equal to 18, t equal to 3 seconds. Okay. Find the distance traveled in the third second. So in the third second, we will find the integration. So the distance traveled will be the integration from second to 2 second to 3 second. And then negative 60 plus 18 dt. Okay, x is the integrate of v dt. Okay, so it will be negative 6t squared over 2 plus 18t from 2 to 3. Then it is negative 3 squared plus 18 3 minus negative 2 squared plus 18 2. So it's negative 27 plus 54 minus negative 12 plus 36. So 27 minus 24. So it is 3. Okay. So 3 meter. Okay. So distance traveled by P in third second is 3 meter. Question number 5. Okay. So for question number 5, we do in the next page here. Question number 5. Acceleration of a particle q travel in straight line given by a equal to 6 cos 2t. T equal to 0. The particle is at point O with a velocity of 10. So find the velocity at time t. Okay. So we know that the v is integrate a dt. So v is integrate 6 cos 2t dt. So it will be integrate of cos is sine. So it's 6 sine 2t over 2 plus c. When t equal to 0, v is 10. So we will have the 10 equal to 3 sine 0 plus c. Sine 0 is 0. So c is 10. So v equal to 3 sine 2t plus 10. Okay, 3 sine 2t plus 10. Find the displacement. So to find the displacement, so we know that the s is integrate v dt. So integrate 3 sine 2t plus 10 dt, then it will be 3 over 2 negative cos 2t plus 10t plus d. When t equal to 0, s equal to 0. So we will have the 0 equal to negative 3 over 2 cos 0 plus 0 plus d. d is 3 over 2. Cos 0 is 1. And then move to the other side. So the s will be negative 3 over 2 cos 2t plus 10t plus 3 over 2. That